Okay, section 2.2 is on Venn diagrams and subsets. So for this section, we're just going to do the basics of Venn diagrams. So we'll just have the one set still, and then next section we'll look at Venn diagrams with 3 sets. So it makes Venn diagrams a little more complicated, or 2 and 3 sets. And then we're going to look at the definition of subsets and do a couple more definitions with that. Okay, so we're going to start off with 2 basic definitions. It says a universal set, symbolized by that is capital U, is a set that contains the elements being considered in a given discussion or problem. Okay, so the universal set is everything that you're considering or everything you're studying in a problem. And then number 2, we have Venn diagrams are used to show the visual relationship among sets. Okay, so we have wrote out our sets in 3 ways from section 1. So that was word description, we had the roster method, and the set builder notation. So we're just writing those out. Venn diagrams, we're actually drawing a picture of the sets. It says the universal set is represented by a region inside of a rectangle, and then subsets within the universal set are usually depicted by circles, which we haven't looked at this definition yet. Okay, but we will in a little bit. That'll make more sense. But basically, subsets just mean the set is within it. Okay, so this is what a basic Venn diagram looks like. The universal set is always a rectangle. Okay, so what you're studying goes in the rectangle. And then sets are always represented by circles. And this is set A, which I know the graphics on this page are not very good, so I'll probably have to write in the elements. When you printed your notes, it might have been a little better. I printed from a copier, so the small ones just didn't show up as well. Okay, so example, it says identify U, A, and the set of elements in U that are not in A. Okay, so first of all, I'm going to rewrite these numbers because they're hard to see. It's 1, 5, 6 in the circle, and then 7 and 9 outside of it. Okay, so we first need to identify the set U, which I'm going to write in roster form. I think that's the easiest way here. And U is just everything you see in this rectangle. So we have a 1, a 5, a 6, a 7, and a 9. Okay, the 1, 5, 6 is also in the circle, but it's also a part of the rectangle. So U is everything you see. Okay, A, that's the set A. That is everything inside the set A, the circle A. So this would be 1, 5, 6. Okay, and then it says the set of elements in U that are not in A. So I'm going to put set in U, but not A. Okay, we're going to have notation for this particular one eventually, but right now we'll just write it out. So that would be 7 and 9. So they're in the rectangle, but not in the set A. Okay, so that is about as simple as we can get for Venn diagrams. Okay, on to page 2. This is just another definition we have for any set A. Within the universal set U, the complement of A, written A prime, is a set of elements in U that are not elements in A. Okay, so that set that we just did, it said the set in U but not in A, that's exactly the complement of A. And we write it as A with a little dash, and I always say A prime here. So we have A prime is equal to X, such that X is an element of the universal set and X is not an element of A. Okay, so it's everything being considered and not in A. Okay, so it says let U equal A, B, C, D, E, F, G, H. M is A, B, F, and N is B, D, E, G, H. We want to find M prime and N prime. Okay, so M prime, that's the set of all elements in U, but they're not in M. Okay, so what I like to do is I just like to compare the U and the M. I just go through the U and see what's in U but not in M. Okay, so we have A and M, so that won't work. B is in M, C is not. So we have C and M prime. D is not. We have E and M, we have F, so this would be also G and H. Okay, so M prime would be C, D, G, H. So all the elements in U that are not in M. N prime, I'm going to do the same thing. N is B, D, E, G, H. Okay, so N prime, you would have an A, we have a B, we don't have a C, we have D, E, we don't have F, but we do have GH. So I got A, C, and F, and with a curly bracket. Okay, next we have the definition of subsets, which we've already kind of looked at, but we haven't looked at the official definition. So this is about middle of page 2. We have set A is a subset of set B expressed. So we have A is a subset of B, so that's how we say this symbol here, if every element in set A is also an element in set B. Okay, so basically you could put set A inside of B. So for example, 1, 3 is a subset of 1, 3, 5. So you have 1, 3 in the set 1, 3, 5. I'm sorry, 1, 3, 4. Okay, so this is a subset of this. Okay, we also have the opposite. The notation A is not a subset of B means A is not a subset of B. Okay, so you just put a line through it to mean not. So the opposite of this, 1, 3, 4 is not a subset of 1, 3 because, and I'll put an explanation here, because 4 is not in the set 1, 3. Okay, so examples for subsets. It says write A is a subset of B or A is not a subset of B. Okay, so we have A is 1, 3, 5, 7. B is 1, 3, 5, 7, 9, 11. So we need to check if A is a subset of B. Okay, so we would check, make sure 1, 3, 5, and 7 is in this set. So 1, 3, 5, 7 is all in that set, so we would have a subset here. Okay, number 2, we have A equals X such that X is a letter in the word proof, and B equals X such that X is a letter in the word roof. Okay, so I'm going to write out what A is. So A is the word proof. So we have a P, an R, an O, and an F. Remember, we don't need to write the O again. And then B is the letter in the word rough, so R, O, F. Okay, so is every element inside of the set B, which we have no. So P is not in B, so this would not be a subset. Okay, and then number 3, A equals X such that X is a day of the week. So Sunday, Monday, Tuesday, all the way through Saturday. And then B is Monday, Tuesday. Okay, so this would also not be a subset, okay, because we have Wednesday, Thursday, Friday, all the way through Saturday in this set, but not in this set. We could over here, and I'm going to put in parentheses, B, since we have ROF is in the set PROF, is a subset of A. That is true. And then we also have over here B is a subset of A, and that is also true. Okay, next definition that goes along with subset is a proper subset. So it says set A is a proper subset of B. Written, we say A, proper subset of B. Notice the line underneath is missing. If set A is a subset of set B and A does not equal B. Okay, so proper subset means they can't equal each other. So for example, top of page 3, you have 1, 3 is a subset of 1, 3, 5. We know that. 1, 3 is also a proper subset of 1, 3, 5 because they're not equal. Okay, so these are not equal sets. So the proper subset works also. Okay, so you can only use proper subsets when they're not equal. Okay, so underneath that we have 1, 3, 5 is a subset of 1, 3, 5 because each of these elements, 1, 3, 5, is in this set. Okay, but 1, 3, 5 is not a proper subset of 1, 3, 5. That's not true because they're equal sets. Okay, so only use proper if they're not equal. To be safe, if you're just trying to write subsets, just always use subset because if they're equal, it still works. Okay, so we want to write subset, proper subset, or both. Okay, so number 1, we have A equals 2, 4, 6, 8. B equals 2, 4, 6, 8, 10. So we could have A as a subset of B because we have 2, 4, 6, 8 and this 2, 4, 6, 8, 10. Okay, they're not equal, so proper subset would also work. So they would both work. Okay, number 2, we have A is 2468 and B is 8426. Okay, so 2468 is in the set 8426, so subset it is. Okay, but they're equal, so only subset works. So I'm going to put a little note in here. So they are equal sets. So proper subset does not work.
Okay, number 3, we have A equals X such that X is a person who lives in LA, and B equals X such that X is a person who lives in California. Okay, so A is the set of all people that lives in LA. B is the set of all the people that live in California. Okay, so everyone that lives in LA also lives in California, so this is a subset, so that works. And then they're not equal because LA is not equal to California, so proper subset would also work. Okay, I also have a little warning here. So it says do not confuse element of with subset. Okay, so you use an element when you're just looking at an element. You use subset when you're looking at sets. Okay, so for example, 4 is an element of 4, 8. Okay, if we were to write 4 is a subset of 4, 8, that's not correct. You have to use set notation for subset and proper subset. So I'll just put a note here. Must use curly brackets for subset and proper subset. Okay, and that is also works opposite. So curly bracket 4 is a subset of 4, 8. Writing 4 is an element of 4, 8 is not correct. So you don't want the curly brackets if you're using the element. So be really careful with that. Okay, we also have one more thing with empty set. It says for any set B, the empty set is a subset of B. Okay, so for example, if you were to say B equals 1, 3, you have that 1 is a subset of B. Okay, the element 1 is a subset of B. 3 is a subset of B. You have 1, 3 is a subset of B. That's the whole set. And then by definition, you also have the empty set as a subset of B. So those would be your 4 subsets. And then it says for any set B other than the empty set, you have that the empty set is a subset of B. Okay, or proper subset, I'm sorry. So proper subset works too for the empty set as long as B isn't the empty set. Okay, and then one more thing. It says the number of subsets of a set within elements is 2 to the n. Okay, this has to be memorized. This will be on the exam. Okay, so this means we can find the number of subsets a set has by counting the number in the set and then taking 2 to that number. Okay, so for example, the example we just did up here, B is 1, 3. That means the cardinal number of B is 2. So there should be number of subsets according to this rule should be 2 to the n, which in this example is 2, which is 4, which we actually had 4 listed here. Okay, so it's 2 to the number of elements in the set. Okay, so we'll just have a small table here, and we're not going to fill all of this in because it'll get too long. We start with the empty set. It has 0 elements. There's no subsets. I'm sorry, the empty set. I'm going to rewrite this as the empty set. I'm going to rewrite this as the empty set, and this one as the empty set. Okay, so this is the empty set. That means there's just one subset. Okay, so you have 1. When you have 1 element, so for example, you just have A, you have the subset of A and the empty set. So you have 2, which is 2 to the 1 equals 2. The next one, we have 2 elements, which is just like this B that we did. You have A, B, the empty set, which is 4. So 2 squared equals 4. We're going to do the A, B, C by hand. Then we'll count it, and then the 4th one we won't write that because it grows quickly. Okay, so we want to list the subsets. So first of all, we have the set with just A. A is a subset of this set. We also have B, so B is a subset of that set. And we also have C. Okay, we also have A, B. So now I'm going to list all of the 2 ones. We have AC. We have BC. Okay, so we have the 2 ones. We also have the whole set A, B, C. Now this one is not proper, okay, but it is a subset. And then we also have the empty set by definition. And that is it. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this work here would go here, listing. We have 8 here. And let's check. That should be 2. 2, though, we have 1, 2, 3 elements. 2 to the 3rd, which is 2 times 2 times 2, which is 8. So that works. Okay, we should have put 3 here. Okay, the next set, A, B, C, D, you have 4 elements. We're not going to write anything for this. There should be 2 to the 4th, which gives you 2 times 2 times 2 times 2, which is 16. So we should have 16 here. Okay, so make sure you have that memorized, this 2 to the n. Okay, and then on to page 4, we have the number of proper subsets of the set n is 2 to the n minus 1. Okay, so coming back to this example down here, I'm just going to put number of proper subsets. Okay, so these are all of the subsets that are not equal. Okay, so A, B, C works. They are subsets, but they're not equal to the set. A, B, A, C, B, C works because they're subsets, but not equal to the set. Empty set works, but this one does not. So we would just do the 8 or 2 to the n minus 1, which is 7. So you would just cross off the whole one for the number of proper subsets. Okay, so you just do 2 to the n and then you subtract them. Okay, so it says find the number of subsets and the number of proper subsets for each set. Okay, so first of all, we need to find n of A, or the cardinal number of A. That is 1, 2, 3, 4, 5. Okay, so the number of subsets is 2 to the 5th, which is 2 times 2 times 2 times 2 times 2. That's really blurry. That is 32. And then the number of proper subsets is just that number minus 1. So 32 minus 1, which is 31. So we have 32 subsets, 31 proper. Okay, number 2, we have b equals x such that x is a natural number, that's a counting number, and 9 is less than or equal to x is less than or equal to 15. So let's go ahead and write out the set first. So b equals, we include 9, 10, 11, 12, 13, 14, and 15. Okay, notice they're both equals here, so you include the endpoints. If it were just 9 less than, you wouldn't include the 9. Or if it was x less than, you wouldn't include the 15. So just be careful with that. N of b is 1, 2, 3, 4, 5, 6, 9, 10, 11. Oops, I forgot 13. Okay, if you guys see me make a mistake on these notes and I don't correct it in the video, please email me because I want to make sure everyone gets the correction. So that's one downfall of doing online classes, is you can't ask questions in class, or you can't correct me if I'm wrong. So I'm sure I'll make a mistake at some point, so please email me or call me if you see this mistake, a mistake. So 1, 2, 3, 4, 5, 6, 7, there's 7. So it's a good thing I caught that. Okay, so number of subsets, that is 2 to the 7th. So I'm going to just take 32 times 2 is 64 times 2 is 128. And then proper subsets would just be 1 less. So 127. Okay, and that ends section 2.2.